Hi guys, welcome to the Khan's Econ Nugget channel. Today I'm going to discuss the price elasticity of demand, its definition, and then how we calculate price elasticity of demand using generic formula as well as the midpoint formula. So let's begin. Uh, First definition, what is the price elasticity of demand? Price elasticity of demand is a measure of magnitude of change in quantity demanded in response to change in price. Let's recall that the law of demand states that when a product's price increases, its quantity demanded decreases, and vice versa. Price elasticity of demand formula measures this magnitude of change in quantity demanded triggered by its change in price. So let's first familiarize ourselves with the generic formula to calculate price elasticity of demand. The generic formula for price elasticity of demand calculation is percent change in quantity demanded over percent change in price, right? So the denominator is the percent change in price, which prompts the consumer to change its quantity demanded decision making. So price change is on the denominator and the quantity demanded change is on the numerator. So now the question is how we calculate percent change. Percent change calculation formula is new value minus old value over old value times 100 for percent. Therefore, if the old price and quantity data of a sandwich is price 1 or original price is $3 per unit, and at that price customer wanted 100 units of sandwiches, and if the price increased became $5 per unit, and at that higher price if customer cut down their quantity demanded to 40 units, then we can apply this formula. We can apply this generic formula to find out what has happened to the uh, price elasticity of demand. So let's see how much was the quantity change. That's on the numerator. So that is our numerator values are basically our new quantity is 40, and we subtract 100 from there. There's the original quantity over original quantity 100 times 100, and our price change percent wise was the new price was $5 a piece, so there's the new value, minus original price $3 a piece, old value, over old value $3 times 100. So then we simplify this, then what do we get? We get negative 60 over 100 times 100 is 60, negative 60, and then over here 5 minus 3 is 2 over 3 times 100 is 67. That's really 66.67, but we can round it up to 67, and then we get the negative 60 divided by 67 is 0.9%. So now how to interpret this result? This 0.9% is the price elasticity of demand of sandwich that will occur if price changes by 1%. So the interpretation of this number is a 1% change in price of sandwich will result in a 0.9% change in its quantity demanded. Now let's see what happens with this generic formula when the numbers change position. In other words, we just did a price increase related problem, right? It was $3 a piece first, and it became $5 a piece, and as a result we found this price elasticity of demand being 0.9%. Now let's keep the number same but just flip the position. So now the next slide we have is a similar number, but now the position has flipped. Now it is originally $5 a sandwich, and it eventually becomes $3. So now it becomes a price decrease related problem. So numbers are same, we just flip position. So now we start with a higher price, $5 a unit, and at that unit price 40 pieces were quantity demanded, and now when price becomes cheaper, $3 a piece, now quantity demanded increases to 100. So notice the number pairs are same, $5 a piece, 40 pieces demanded, $3 a piece, 100 pieces demanded. So numbers are same as the previous problem, but only change has occurred is the new price versus old price and new quantity versus old quantity. In the previous slide, price was starting with low, became high, and over here now price is starting with high and becoming low. So now, of course, our percent change formula will dictate us to calculate them now differently, because now the new price is $3, so it's 3, and the old price is $5, and similarly our new quantity is now 100 pieces and old quantity is 40 pieces. So now we apply the same percent change formula, new value minus old value over old value times 100, and now we redo the numbers and we get a result of 3.75%. So now how to interpret this number? A 1% change in the price of sandwich will lead to a 3.75% change in its quantity demanded. Note that the same sandwiches we are using, but because of their occurrence precedence, sometimes it's a price increase related precedence, sometimes it's a price drop related precedence. Because of that, now the numbers are different. Now we're getting 3.75% as opposed to previously found 0.9%. So that is a problem, right? Same product, sandwich, but depending on which price we assume first, the higher one or the lower one, we get a different result. So to avoid this kind of problem, we need a better formula called midpoint formula. So the midpoint formula of price elasticity of demand calculation is this: change in quantity, not percent change though, it's just a difference between those two quantities is the change in quantity, over the middle point of those two quantities. How do we get middle point of two numbers? We add those two numbers up and divide them by 2. And in the denominator, change in price, not the percent change, there's the absolute difference between those two numbers. And how do we get the midpoint of those two prices? We add those two prices and divide that by 2. So now what we have? On the quantity, we have the difference between 40 and 100 is 60, and the middle point of 40 and 100 is 140 divided by 2, that gives us 70. And on the denominator, what we got? We got the difference between $5 and $3 is $2, and the middle point of $5 and $3 is 5 plus 3, 8 divided by 2 is $4. Then we simplify this math, we get 0.86 over 0.50, that gives us 1.72%. So how to interpret this number? A 1% change in price now will lead to a 1.72% changes in the quantity demanded of the sandwich. And notice, if you are using this formula, the midpoint formula, whether we are setting up the problem as a price increase related problem or we are setting it up as a price drop related problem, either way we get the same result, 1.72%. And so because this number 1.72% is greater than 1, we call it an elastic demand. So sandwich price is elastic because the elasticity value is greater than 1. And what if we have gotten some value less than 1? Then we would have said this product's elasticity is inelastic. So the product's elasticity value greater than 1, we call that elastic product, price elasticity of demand. And if we happen to get a value less than 1, then we would have called it an inelastic demand. So hopefully the concept is now clear, the difference between generic formula to calculate price elasticity of demand and the midpoint formula to calculate price elasticity of demand. If you have any more question, please email me or comment on this channel and subscribe to this channel. and ask me in class any clarifying questions as well. Thank you so very much.